All right, here is 3.2.1. It is the addition and subtraction with opposites. In blue there it says we're going to connect this movement along a number line with the addition and subtraction of integers and opposites. Integers are numbers that are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. And it also includes all of the negative numbers, -1, -2, -3, -4, -5. It does not include fractions or decimals. All right, so I'm going to go quickly through this thing because it is kind of a longer video, but you can always pause and go back and rewind and re-listen to any of it. All right, I have a couple of warm-up problems in here. Why don't you go ahead and pause and try these two warm-up videos. Okay, so I'm going to quickly go through this as I just mentioned. Hopefully you just did it yourself. 5 times what number is 35? That's 7. This has to be a giant 1, so it's 7 over 7. 4 times 7 is 28. There we go. 4/5 is an equivalent fraction to 28 35ths. And now we can do with these giant ones here. 8 on the right. 8 times what number is 16? And that's a 2, right? 8 times 2 is 16. So to be a giant 1, this has to be 2, right? But some number times 2 is 20, and that has to be 10. 10 times 2 is 20, right? Okay, hopefully you tried these two fractions down below. I actually showed all of their work kind of down here, almost all of the work right here. On the left side there, in the black giant ones, we had 6/7 plus 2/3. And I was working on multiplying it, and I used the colors here. You notice I used the 3 from the 2/3 to create the 3 over 3, and I used the 7 from 6/7 to create 7 over 7. And those giant ones helped me to create 18/21 plus 14/21. I have to have those common denominators, right? 18/21 plus 14/21 is 32/21. 32/21 is also equal to, oh, I hit the eraser, 1 over 11/21. Okay, and that's simplified as much as possible. Over here on the right in the purple, I also did the same concept, but I have 12/30 plus 25/30, and that is 37/30, right? Also would be 1 and 7/30. Okay, make sure you reduce as much as possible. So 37/30 is a good answer, or 1 and 7/30. It does not have to be a mixed number. All right, let's get moving today. So today we're going to talk a little bit about frogs. You can see my little froggy I made on there. And we're going to talk about him on a number line. And that frog's going to move to the right. He's also going to move to the left, right? And you can see all those integers I was just talking about. And I put little arrows on there indicating that it goes on to infinity in either direction. All right, what I would like you to do is to pause, and in the description of this video I have a link to another video to the Calaveras County Frog Jumping Contest, and that would remind you of what you guys saw earlier in the year.
Number one, the frog must
check this all out later. It's just a quick video that we had way at the beginning of the year about this, and maybe you had forgotten about how that worked. Okay, all right, now that you've watched that video, what we have is we got this sort of situation here. If the frog starts at 3, and notice up above I put that frog at 3, and it hops to the right 4 units, right? So we hop to the right 4 units. So 1, 2, 3, 4 right here, right? And then to the left 7 units, so I'm trying to coordinate my colors here, 7 units. To go back would put it back at 0, that's 7 units backwards, right? And to the right 6 units, oh, I didn't even erase my answer from before, did I? 6 units, that puts me at 6, right? So my answer is 6 there. Frog will end up at 6, okay? So notice here we're working on talking about the frog movement from the right and to the left. And eventually what we need to do is we need to start using this as addition and subtraction, right? That was our goal for today. All right. So here we go, got our frog again. If the frog starts at 3, makes 3 hops to the right, and lands on 10, list the lengths of 2 possible combinations of hops that will get it from 3 to 10. So we got to make 3 hops. So I could just do, 2, right? That's like a plus 2 in there. Then I could do a 3 here. That's like a plus 3. And then what would I need? I'd need 2 more to finish that, right? So there I could say, 2. I could add 2 to it, then I could add 3, and then I could add 2. And this is starting to connect our addition and subtraction to this. And we'll dive deeper into that, and it'll get a little bit better as we go. Okay? Do note that 2 plus 3 plus 2 does not equal 10. Okay? It's important to know that we have to start somewhere, and we start at 3 to begin with. So, okay. Here we go, we got our frog again. If the frog starts at 3, could the frog land on a positive number if it makes 3 hops to the left? Pause and try this for a moment. All right, hopefully you tried this out, took 3 hops. The smallest hop I can make right now is 1 unit, 2, then 3. Could it make it to positive? The answer is no. 0 is not positive, it's not negative either. But it can't make it to, it would not be a positive number unless you had jumps that were by halves or something to that effect, a decimal or a fraction. So you could make the argument that it's possible, but not with integers, right? Not with integers. Okay. All right, let's talk a little bit more about frogs. I had to shift this one over because it needed some space, so notice my frog is way to the left, even though he still starts at 3. If the frog starts at 3, makes 2 hops of the same length to the right, and then hops 6 units to the left, if the frog ended up at 11 on the number line, how long were the first 2 hops? So what they're saying is there was 1, 2, they were equal distance, and then it had to make 6 backwards, or 6 to the left, to land on 11, right? Okay. Well, with some work, what we would find out that if I had to go 6 backwards to get there, couldn't I just do like 6 this way? 1, 2, 3, 4, 5, 6. But then how do I get from 17, which that almost doesn't even look like a 17, right? How do I get from 17 and all the way back to 3? But I have to do it in 2 equal hops, right? Well, if we start playing around with this a little bit, what you'll find is that it will be hops of 7, 2 hops of 7. So there's a plus 7 here and a plus 7 here. And then what you found out is it had to go backwards 6 to get there. And you could check my numbers to do that. But it takes some time and working through, and I wish you'd kind of like pause and play around with this one to get that. That's takes a little bit to just kind of wrap your head around it. All right, we have a second to look at the math notes. Here are the math notes. Pause the video right now, read through this, and then jump back in this in just a little bit. Okay? All right, now that you looked at the math notes, hopefully you start to understand what opposites mean, right? So when we talk about like the 3 where that frog is currently, and I'll even keep this down so that we can't even just see what we're writing down below there, or what's written below. The opposite of 3 is negative 3, right? Right, negative 3. Or if I said, what's the opposite of negative 5? The opposite of negative 5 is positive 5. What it is the same number, but it depends on the value in front of it. Okay. Now, what's important to know is that it's the same distance away from 0. So, for example, if I'm looking at this one and I say 3 and negative 3, right? Negative 3 is the opposite of 3, but notice that they're both the same distance away from 0. That becomes an important part for us to discuss, okay? So here we go. The frog starts at 3, jumps once to the right, and 1 jump to the left. If the frog started 3 units from 0, right where it is there, and ended 3 units away from 0, what are the possible lengths of the jumps? Well, the first jump, it just says, is 1 to the right. It doesn't even say, right? What does it say? It says jumps once to the right and 1 jump to the left. It doesn't even say how far the jump is. Let's just say it went 4. But it had to jump again to the left, but the frog, right? The frog had to be 3 units and ended 3 units away from 0. Well, the frog could have been right here, right? It could have jumped forward 4, or to the right 4, right? But then it could have what? Just subtracted 4, gone right back to the same spot. But let's not forget that this is also 3 spots away from 0. How did I get from 7 to negative 3? That is actually a movement of 10. I subtracted 10. You can count that out. what we really want to start thinking is distance away from 0. Start to at least keep that in our mind as we're moving forward, okay? All right. Now, describe how the frog would end up meet the following requirements. From 3, make 1 hop and land on 6. All right, so let's take this. So from 3, make 1 hop and land on 6. So we started at 3, and how did we land on 6? We would have to move 3 to the right, right? There it is, right? There's my 3, and it went 1, 2, 3 to get to 6. From 6, we're going to make, now down there in the black, from 6, make 1 hop and land on the opposite of 6. All right, so here we go. We got to make 1 to the opposite of 6 is negative 6, right? So what was that movement? That movement was a minus 12, right? A minus 12 to get from 6 all the way to the opposite of 6. From the opposite of 6, which we already declared is the negative 6, make 1 hop and land on the opposite of the opposite of 6. Ooh, the opposite of the opposite of 6. The opposite of the opposite of 6 is 6. The opposite of 6 is negative 6, but the opposite of the opposite is positive 6. What a crazy deal. That would be adding 12, right? Weird to think of the opposite of the opposite, huh? All right, how could we write that opposite of 6? Using math symbols, where would you be on the number line? Well, if we first thought about this as what is the opposite of 6, we would write that like that, right? A negative 6. But if we're doing the opposite of the opposite, we would put another sign in here. Another opposite or negative sign in there to do that, right? Now, in math, that would be, I guess, right, but we would always want to add a little some symbols in here to help that. And what we do is we look at the parentheses, and the parentheses help us to say, hey, inside of that is the opposite of 6. But that one negative sign outside of there makes it the opposite of the opposite of 6. And it kind of helps to keep things clear, because if I have this, this, and this, that's a little bit more confusing. I'm not sure if I'm supposed to have 2 negatives. Did my pencil screw up? Is it really supposed to be a big negative? How are we doing that, right? And so by putting those parentheses, that really helps to make sure we see that there are 2 opposites in there, the opposite of the opposite. All right, Elliot was designing a video game of a frog jumping. For his first game, the frog starts at 3, hops to the right 4 units, and to the left 7 units, and then to the right 6 units. He wrote it as the following expression: 3 plus 4 minus 7 plus 6. Explain. Explain, right? Well, where's the 3? The frog starts at 3. That's why we start with that number 3, right? And then hops to the right 4 units. There's my to the right 4 units, right? Notice now we're starting to connect this talk on a number line with addition and subtraction with opposites, right? Then we have what? To the left 7 units. There's my left 7 units. That's the negative, right? And then lastly, what happens then to the right 6 units? To the right 6 units would mean that we're going to go to the right. So that's a plus, or move into the right direction, okay? So notice here a couple of things. Number 1, the yellow part. It starts at 3, so we start with the number 3. And then whenever we have a movement to the right, it's a plus. Whenever we have a movement to the left, it's a minus. Okay? So if the expression was 5 minus 10 plus 2 plus 1, describe the frog's movements. Where did the frog end up? Well, where does the frog start, right? Where does that frog start? The frog starts at 5. Then we subtract 10 or move 10 to the left. Then we add 2. Then we add 1. Where did our frog end up? At negative 2. Okay, you can pause and recheck that if you're thinking about it. Next game is negative 5 plus 10. Where does the frog start? The frog starts at negative 5, and it goes where? We're going to add 10. Notice it does not end. Oops, 1 too far. Notice the frog does not end at 10, but the frog is moved 10 units from negative 5. The frog starts at negative 5, and I'm just putting it right here by the starts part, and it ends at where? Positive 5 in this case. Okay. Write an expression for the following game. Start at the opposite of negative 3. The opposite of negative 3. Hop 5 units to the left, so subtract 5. 9 units to the right, so that's plus 9, and then hop to its opposite position. Ooh. Well, where did that frog end up? Let's check this out. So the opposite of 3, that's frog starts right here. Then we had to subtract 5, right? Subtract 5, that is down here to negative 3. Then we added 9. 9 puts me at 7. Then what? We had to hop to its opposite position. Well, the opposite position is all the way here to negative 7, right? There, so we got to kind of put all of that all together in that same time, right? I'm talking about the opposite of the opposites, the movements to the right, to the left, and all of the opposite positions. All right, where does the frog start in this expression? The opposite of the opposite of negative 2, or opposite of 2, right? All right, and I think we've been starting to play around with this up here, up above, right? That's really 2 plus 6, right? 2 plus 6, where does it land? It lands at 8, doesn't it? Okay, so the opposite of 2. So that minus sign, and I have these colors coordinated as we read through this, that minus sign, that minus symbol can be translated into the words subtract, like in blue, 5 subtract 3, or we can also use the words take away, like 3 take away 5. We also can talk about it using negative, and you can see the sign there. And actually, I could even rewrite this like here. No, I would not want to do that right now. Negative 3 plus 4, or 4 plus negative 3. And then we can also talk about the opposite of 1 plus 7, or 7 plus the opposite of 1. Okay? Hopefully that sums things up. Let me know if you have other questions. Have a great day.